Welcome to science class. Today we are going to learn about alternative energy. Alternative to what? Fossil fuels. As we stated last week, fossil fuels dominate the energy sector. The big energy domains are transportation, generating electricity, and manufacturing. Alternative energy can help us tackle the generating electricity part, but that's really it. Alternative energy is not the same as renewable energy. Geothermal and nuclear power, which we will cover today, are non-renewable. It doesn't mean green energy either. Nuclear power generates pollution, and although a wind turbine doesn't emit any pollution, the manufacturing of it does. Don't get me wrong, I'm very excited about alternative and green energy, but I will always try to give you the entire story. There are positives and negatives to everything. This world is full of fake news, biased information sources, disinformation campaigns, and even Russian hacking for crap's sake. My loyalties lie to what is true. Sometimes the truth hurts, but that's when meaningful learning happens. Let's get started. So today we are going to cover solar, wind, hydroelectric, geothermal, and nuclear energy. But we need to review what we talked about last week just a tiny bit. Virtually all modern activities, from serious work to just leisure activities, require energy, and electricity is usually the major component, although sometimes it's transportation. Fossil fuels have been our go-to method because they are cheap, plentiful, energy-dense, easy to transport, and reliable. We almost always use these energy sources to either create mechanical power, such as what a car engine does by burning gasoline, or to make electricity, such as burning coal to power electric generators. In reality, burning coal also creates mechanical power. The heat from the coal creates steam, and the kinetic energy from the steam spins a generator like the one that powered the world's worst light bulb in the last video. Alternative forms of energy are used almost exclusively for generating electricity, so our transportation needs are not yet satisfiable through alternative energy, which is a big deal. Last year, transportation overtook generating electricity as the main producer of carbon dioxide in the United States for the first time ever. The electric car should not yet be considered to be powered by alternative energy because most of the electricity that charges its batteries is made by fossil fuels. Theoretically, an electric car could be powered totally by alternatives if dams and wind turbines and solar panels were the only thing plugged into the power grid. Maybe that will be the case in the near future. Who knows? The first powered flight in an airplane happened in 1903. That flight only went 260 meters. 63 years later, we flew to the moon, which is 400,000 kilometers away. Nobody could have seen that kind of progress coming, so I'm not going to try and guess the future of alternative energy. Back to electricity. For the typical household, air conditioning is the most energy-intensive component of your home. Heating is second if your house has electric heaters. Other homes burn natural gas to heat the rooms, and the water, which is the next leading use of energy in a typical household. So how can we get power to the house in alternative ways? Let's begin with solar power. Solar energy can be harnessed in a few different ways. You can make electricity directly or indirectly, or solar energy can be trapped to provide heating. The major benefits of solar power is that it's free, non-polluting, and usually requires very little maintenance. The drawbacks are that obviously you can only utilize solar power at certain latitudes, in certain climates, and only at certain hours of the day. Solar panels contain what's called photovoltaic cells, which absorb sunlight and, through some wizardry that I don't understand, creates a constant, relatively weak current. Solar panels have gotten exponentially cheaper and more powerful over the decades, like computers have. One day, a solar panel that fits on the roof of a car might provide enough energy to power that car, but we're not even close yet. The problem with solar panels is that they only make electricity while they are being struck with sunlight. The best hours of the day to get solar power are from around 10 in the morning to 6 in the evening. The vast majority of this time, people are spending at work or school, so they aren't utilizing this energy very well. To be fair, a lot of things in your house would be using the electricity, and you would be getting all of that for free. The fridge needs to always run. Your air conditioning or heating is probably left on all day, even when you're gone, and a few other items. Elon Musk, who is up to all kinds of half crazy, half awesome things right now, has developed these battery packs for your house. Each battery pack is charged by solar panels, so when you come home, you can use the energy that they stored all day while you were at work. Turn on the lights, TV, music, and it's all being powered for free. Obviously, you have to buy the equipment first, but the payback time for solar panel energy shrinks more and more every year. Solar panels have no moving parts, so you shouldn't expect to have to repair them either. Solar mirrors can also generate electricity. Solar mirrors reflect light to a tower, which may be filled with water. The heat these mirrors create is incredible, so the water boils, making steam, and using that steam to spin a generator. Some households have big black boxes on the roof. These are solar collectors. The air inside gets hot, and that heat can be used for simple tasks like heating rooms or heating water. No need for any electricity. Simply designing a house the right way can also take advantage of the sun. South-facing windows, if you live in the northern hemisphere, collect sunlight all day. Even when temperatures are close to freezing, the sun can feel very warm indeed through these windows, and it heats the air in your house, reducing the need to use natural gas or electric heaters. The 5 countries that produce the greatest number of megawatts from electricity from solar panels are Germany, Italy, the United States, Japan, and China. However, solar only accounts for between 1.8 and 7.7% of their electricity demands. Honduras generates 12.5% of its electricity from solar, higher than any country. But the total amount of electricity that is generated is much lower than larger, more industrious countries. China's solar capacity is 343,000 megawatts, whereas Honduras's is only 391 megawatts. Wind energy in the modern age is captured entirely by wind turbines. Wind turbine blades, which are huge, are shaped to catch the wind and create rotation. The inside of a wind turbine's head contains an electric generator, which spins with the blades to make electricity. They're really very simple devices, apart from the fact that they're huge. Wind energy has been the fastest growing alternative energy method by far in the United States in the last 10 years. Like with oil, Texas is the leader in the United States in producing wind power. The positive with wind energy is that turbines don't have any emissions themselves. Drawbacks are that the wind is intermittent. It comes and goes. Also, the resources required to build the wind energy infrastructure are gigantic. It takes around 542 tons of iron and steel to produce a single megawatt of power from the wind. By comparison, it only takes 34 tons of iron or steel for a coal plant and just over 5 tons for a natural gas plant to do the same thing. That's why transportable is one of the great strengths of fossil fuels. It allows you to bring in the energy-dense fossil fuels to make a lot of electricity in a central location, rather than spreading it all around. Hydroelectric energy is a system of converting the potential energy of water into kinetic energy, which is used to drive turbines. This time, the velocity of the flowing water itself spins the turbines. No steam is made, unlike all other power plants. The majority of a dam is just to back the water up. River channels are widened excessively once the dam is built. Lake Mead isn't really a lake at all. Before the 1930s, it didn't even exist. Lake Mead is a reservoir created by the Hoover Dam. Once the Colorado River was dammed, the water behind the dam filled all the way to the top of the dam. This made the river around 200 meters deeper. Hydroelectric power is great because the water always flows, so you always make electricity, and the amount of electricity made is pretty stable. No need to worry about shortages or overproduction. Hydroelectric power has long been the dominating alternative energy producer, and it will likely continue to be at least for a few more decades. Hydroelectric energy is also cheap because you don't import your fuel, the river is your fuel. The drawback is that we can only build so many dams. Hydroelectric output has been virtually static in the last 50 years in the United States. Worldwide, hydroelectric only accounts for around 6% of the total global electricity production. It could theoretically double its current capacity, but that's about it. There are environmental and political hazards associated with dams as well, but we'll talk about them in the next video. Next up, geothermal energy. So electric motors are really simple, but they do still need to move. Specifically, they need to spin or rotate. That's the only way to make electricity with them. Steam has a lot of kinetic energy, and we have enough water to make it, so steam is used to spin turbines, which in turn spin these generators. That's why coal and natural gas are burned, to boil water. It's also what a nuclear power plant does. There just isn't any combustion. Geothermal energy is the tapping of steam that naturally exists under the surface. Geothermal is great and fairly simple to operate, but it has some significant shortcomings. First of all, only 12 countries in the entire world have the capacity to generate more than 200 megawatts per second. Texas alone produces over 3.5 times more electricity from wind turbines than the entire globe does from geothermal. Geothermal energy is also finite. Eventually you run out of steam. This can be prolonged by pumping water back into the ground, but it isn't a process that can go on forever. Still, in some countries, they get a large share of their needs from geothermal, so we cannot discount that. If it makes sense to build a geothermal plant somewhere, by all means do it. This steam is created from proximity to magma chambers or cooling igneous rocks, relatively close to the surface. Iceland, a volcanic island nation, gets a good share of their electricity from geothermal. Lastly, there's nuclear energy. Of all the alternative energy types we have talked about, nuclear energy is the most unfairly treated, least understood type of energy. It is also the one type of alternative energy that is most like fossil fuels, meaning it has the same benefits. Let's actually get the misconceptions out of the way first. 1. Nuclear power plants do not bombard their surroundings with radiation. Human beings work in nuclear power plants, and they don't come home sprouting 3 arms and 12 eyeballs. Is the stuff inside a nuclear power plant radioactive? Yes. Everything is radioactive to some degree. A human being releases more radioactivity when they stand next to you than a power plant does if it is built literally across the street from you. 2. The type of uranium or thorium used in a power plant cannot explode. It's impossible. Nuclear explosion is not an intrinsic property of uranium. You have to enrich and alter it significantly. Why do you think it cost billions of dollars and 4 years for the Los Alamos scientists to build the first bomb? Because they were changing the fundamental nature of matter. Did an explosion happen at Chernobyl? Yes. It was an explosion caused by a combination of total incompetence and a buildup of too much steam. 3. Nuclear power is not intrinsically dangerous. Something like 41 people have been killed directly in nuclear power plant accidents. 30 of them alone were killed from the Chernobyl explosion. The Fukushima incident was caused by a tsunami, so that's a little unfair to pick on that. From the years 2003 to 2013, an average of 108 oil and gas industry extraction workers a year died. Now that we have that out of the way, how does a nuclear power plant work? The infrastructure of a nuclear power plant is extremely similar to a coal-burning power plant. The radioactive isotopes, which come in long bars we call rods, get very hot and their heat boils water, makes steam, spins turbines, and powers generators. What you see coming off of the cooling towers in nuclear plants is steam. No radioactive waste is flying into the air. Radioactive isotopes are incredibly energy dense. The energy density of anthracite coal is 38 megajoules per liter. Uranium's energy density is over 1.5 million megajoules per liter, and a 12-foot uranium rod can last 6 years in a power plant. Because these isotopes are solid, they are transportable and easy to manipulate, just like coal. Nuclear power actually produces almost 20% of the United States' electricity, but our capacity to generate electricity with nuclear power has barely increased since the 1980s, when you know what happened. The real disadvantage to nuclear power, apart from the fact that people think it's scary, which isn't a real disadvantage, it's just one of the many things wrong with people, is that a nuclear power plant is very expensive to build and maintain. However, if we started investing more in nuclear power, the cost of production and maintenance would go down. That's how literally everything in a market economy works. Well, except for medicine. But again, that's one of the many things wrong with people. Next time, we will talk about natural resources such as water, trees, and the air, as well as human impact. Thanks for watching.